number of atoms in a compound, and it tells us the number of atoms in the lowest number ratio possible. So we're going to do one example. So you've been told an oxide of silicon, an oxide of silicon contains 47% by mass. An oxide of silicon contains 47% by mass silicon. What is the empirical formula? Okay, so you're told to give the empirical. Give the empirical formula. So what do? The first thing you do is you say, so you've been given the mass of silicon as 28 and oxygen as 16. So the first thing you do is you say this oxide, we've been told this oxide contains 47% by mass silicon. Then it means the formula of, so you're told it's a oxide of silicon, meaning it's silicon what? It is silicon oxide. It is silicon oxide, meaning it is made up of two elements, silicon and what? And oxygen only. So it means if 47% is silicon, then the other remaining percent is what? It's oxygen. So the mass of oxygen by percentage will be 100%. You subtract 47 what? 47% to get you there, to get you 53 what? 53%, which is the mass of your oxygen atom in silicon oxide. Now after doing that, you come right here your element. So this is how you work out empirical formula. You write element there, okay, and then you write the percentage composition by mass. So after you've written your element, on the side you write the elements present, which is silicon and you have oxygen. You've written the percentage composition by mass. So the percentage composition of silicon we were told was 47, and for oxygen is what? It is 53. Now you come and you write the relative atomic mass of the different atoms. So the relative atomic mass of silicon is going to be 28, so you're going to write there 28. For oxygen is going to be what? It's going to be 16, so you write 16. The mass that you're given there was the relative, or is the relative atomic mass. After that, now we say the empirical formula gives us the number of atoms in the lowest mole ratio. So we want to work out the number of moles to see the number of silicon and oxygen atoms in their simplest mole ratio. So we write here number of what? Number of moles. So how do you get moles? Moles is given by calculating. You say moles is given by dividing or by putting mass over molar mass. So it's going to be your mass, you divide by your molar mass. Your mass 53, you divide by your molar mass. So the moles that you're going to get here of silicon is going to be what? 1.68, while for oxygen is going to be 3.31 moles. So let us look at for the mole ratio. The mole ratio is going to be what? It's going to be, you take your number of moles, you divide by the lowest mole, okay, that you have here. So the lowest mole is 1.68, which is definitely smaller than 3.31. As you get what? You get 1. The mole ratio here is 1. You take your 3.31, you divide by the lowest mole, which is 1.68. You get your mole ratio as 1.94, which is the same as 2. Okay, so the simplest mole ratio here of silicon to oxygen is 1 is to what? 1 is to 2. So it means the atoms of silicon and oxygen atoms in the lowest mole ratio is 1 is to 2, thus giving us the formula of silicon oxide as Si1 O2. So that is how you calculate empirical formula. Okay, that is how you calculate your empirical formula.